these demos working, which in itself was kind of interesting. Let me get rid of Opera, I don't need it. What happened was, when this, okay, here's this vulnerable message board. Let me go back here. So you put in your name, and I'm gonna make this big, all right. And your name is Sam, say enter. It says, hello, Sam. That in itself is a vulnerability because I could have put scripts in my name, but I prefer to put them elsewhere. So here I'm gonna erase the old comments. Now, if I put a comment here like hi, I say hi, all right, and post comment, this appears, oh, it didn't erase the old comments, how rude. Probably I forgot to fix that function. Anyway, so the hi I put should have appeared on there, but I'm not seeing it. What happens if I refresh this? All right, anyway, let's see if I can do anything or if my demos are still shot. Here's the cross-site scripting vulnerability. And, right, I do appear to have hosted it. Somehow I got this up there and I can't change it. Anyway, this is the one I wanted to show you from before. I showed you the others on the other page. This is the iframe that adds content from a different server. So now you're at samsclass.info, but you're seeing content from City College in this little frame. And this is what typically happens with SQL injection mass defacements. When they find something like a WordPress vulnerability that makes 1 million sites vulnerable, they'll write a script and add a little extra HTML code to all the pages. And it will add an iframe like this that points to a third server. They make it size 0 so you can't see it. And now all those pages are carrying malware from a third server. And the people that run the pages will not understand this. If they run a virus scan on their server, there are no malicious files on their server. If they look at the traffic coming off their server, there is no malicious traffic there. Well, there would be. In here, this page, but what happens is, like an ad, content is added from somewhere else. And what happens is, if the people that have pages infected in this manner don't figure it out and clean it, then sooner or later Google will notice it, and Microsoft will notice it, and the antivirus companies like McAfee will notice it, and they will start blocking your page. You try to go there and Google says, this is an unsafe site, don't go there. And Microsoft says, Internet Explorer has detected that this page is serving malware, don't go there. And that's usually their only clue. I remember I called up a high school that had this defacement. They had a defacement to illegal drug sales on their page, and I got their server administrator, and they didn't care. It only affected people that came in from Google. They said, well, I don't think our students are going to come in from Google. You're wasting my time, and hung up on me. In general, telling people about their problems is usually useless. If they have any intelligence, they'll have a bug bounty program. If they don't have a bug bounty program, they are so stupid that they cannot be helped, and you just have to let them get hacked. And after they get hacked enough times, they will eventually wise up and realize that security matters. But until they've been hurt a few times, it's typically impossible to communicate security problems to them. The only thing they will observe is, you're bothering me, you must be a criminal, you must be locked up, so I don't have to hear this unpleasant stuff anymore. Anyway.
So you say this was an iframe that got reduced?
Yeah, that's an iframe you can see. You can make it size 0 so it's invisible. And then it's... It doesn't mean you're a bot. It means your page is infected with malware. It means your server is now serving up malware from a third-party site. But it is a way, if I find a bank with a cross-site scripting vulnerability, or with a SQL injection vulnerability, or some other lets me upload a file or modify a file, I can add that to their page. And now all the bank customers will get infected with malware. And the bank will not understand that it's their fault. This is the problem. When you let users put content on your site, you have a responsibility to clean that content. And now we're getting to some place where most people will accept that if you let people put up malicious code on your site that hurts people, you have an obligation to clean it off. And the thing we're living through right now, because of Gamergate and all the controversy, is if you let people put up other kind of harmful material, like malicious political lies, fake news, rape threats, threats of violence, you're probably responsible for that too. And we're slowly living through the development of what are the rules and how much do you have to censor other kinds of material on your site. Anyway, so if you have cross-site scripting vulnerability, I can steal other people's authentication cookie. So I can break into people's accounts. If there's cross-site scripting on eBay, there's been one for a while, you can steal someone else's cookie and now get into their eBay account. That's session hijacking. You can harvest stored passwords from their browser. If they have a password manager, quite a few password managers have been shown to be vulnerable to that. And if they have another vulnerability on their machine, I might be able to take over their machine through some kind of browser exploit. You can redirect the web page to another site. You can do many things with cross-site scripting. One user can hurt other users, but most companies don't take it seriously because you cannot directly attack the company server. you can bounce an attack off the server and hurt somebody else, but the company isn't directly damaged, so it's not a high priority for them to fix it typically. Anyway, WebGoat is one of the training tools I used to use in this class. I switched to that Security Shepherd, thinking it might be more modern, but both of these, one of the many things that OWASP does is make training tools that are websites with many vulnerabilities in them so you can practice these things. So if you're going to find out how vulnerable web page is, you can consider how their dynamic web pages work, how they send data to other servers, and what kind of authentication is used. It's very often a weak spot. How does the user prove who they are, and how does the server keep track of that? And then in general, what platforms are used. A static web page without any login or dynamic content is of course a smaller risk, but there are still some things you can do, like directory traversal. You can do .. to traverse to other directories. This usually doesn't happen in modern versions of IIS, but it did for a while. And one simple cure for, and the point here is, I've been thinking I need to add like a basic command line project to my classes, because a lot of people never lived through MS-DOS days like me, and they don't know how to traverse a tree structured directory. Let's see if I can get somewhere on the City College webpage. Yeah, here we are. So now I'm at City College. This is the name of the server. Now I'm in a folder called EN, a folder called Employee Services, and Office of Instruction. Now what you can do in a tree structured directory, if I wanted to get back to the main page, I could put .. / .. and that will go up out of the Employee Services into here, and the second .. / will go back here. So all of that will put me back home again. And if the structure of the web server is correct, the user coming in from the internet only has permission to get in the HTML folder and subfolders. But if it's not, I can go up from here, .. .. ets password. If it's a Linux system, there's this file which has the password, which has the user accounts. If it's a Windows system, you go places like this, system32cmd.exe, and in old systems, this would work, and you get a command prompt right in the browser. You can type in DOS commands and take over the server. In modern systems, it will just detect that you're trying to get out of where you're supposed to be. This one here filtered out the .. so now it's looking for Windows System 32 and then not finding the page. Now notice down here, this is a pretty good error. 404 and explains 404. Sloppier pages will now tell you exactly what version of web server they're running and all that jazz. You should make your error messages so they don't tell people things that they don't need to know. That's a pretty good one. City College used to have a variety of hilariously bad ones. Anyway, but that's directory traversal. And that's an attack that works even if you don't have any active content on the page. And if you defend yourself by just removing the characters .. / you can trick it in by encoding it. And one trick was this %C1, %9C is a Unicode version of the same character, as if you were working in a Japanese language machine or something. It uses a different character set. And it's common that filters don't think of that. So attackers find ways to overcome filters by sneaking the forbidden characters in an unusual form, so the filter doesn't block it. Anyway, so SQL injection is a big deal, of course. The point of SQL injection is you have these structured query language queries, like this one will select all the data from the customer table where username is name and password is PW. So this is the kind of thing that happens when you log in. And the point is, if you put in, this is the most famous simple beginner string, is apostrophe or 1 = 1 .. And now it changes into this. Select everything from customer where username equals empty or 1 = 1 .. starts a comment, so everything else is ignored. So now, if the username is empty or 1 = 1, that is always true because there are two conditions. This might not be true, but that is always true. And the OR statement means the combined statement is true. So the programming logic will do whatever it was going to do if that condition was true, which typically authenticates you as the first user in the database, which is usually the administrator. So it is, for SQL injection vulnerable servers, you can put in a string like that for your username and password and often just get in as the administrator. In practice, if you're doing the CTFs like Pico CTF, which I highly recommend, or the projects where you do things like the old Pico CTF from 2014 or Security Shepherd, you'll find that in practice it's a lot tougher. You have to find the right comment character. It depends on which version of SQL you have. But after a little bit of practice, you get pretty good at this, and it's good, clean fun. Here's the training product that Jeremy Hammond put up before he got either a 10-year or a life sentence for hacking repeatedly in Anonymous and other groups. He put up a training tool. And one of his training tools where he hacked into a bank that was vulnerable to SQL injection. And if you just went to the search engine and put in that, it would then dump out all the names and passwords in the database. But that's Jeremy Hammond. I used to have him in this class for homework. I'm not sure, I don't know if I still do. I think I probably got tired of it. But he eventually got locked up. He was a freegan, lived entirely off vegan food found in trash cans as a political statement. And he got hacked. He has ideas to be like Robin Hood, hack the rich and give to the poor. And he got caught time over and over and over again for it until they finally locked him up. He was one of the 8 people in anti-sec, from LulzSec, from Anonymous, that decided to hack the FBI and high-profile government targets, which was in fact an FBI sting operation brought in by Sabu, who had been turned and tricked him into attacking the government directly in order to create big enough crimes to lock them up, and he's now locked up for a really long time. It's a shame. He's a very good teacher. His site is very good as a training tool, but his politics are so extreme and he won't knock it off that he ended up locked up. Yeah?
So it's an operational security foul? That's how you got caught? Or?
Yes, that's another issue. Because they formed a group, then one of them could roll on the other. That's why Kevin Mitnick, that was his lesson too. After he did his time in solitary, he came out, he said, the only way to be a criminal hacker is to act alone. They will all just betray you. And that's why all the groups that were popular in 2011, 2012, they're all gone. The only people that survive are people that work completely alone, like the Jester. If you have no friends at all, then you have the possibility of not making a mistake. But if you have friends, they will rat you out. Anyway, Havij and SQL Map you've done in the project. This just automatically pumps all the data out of a server. And SQL Map is the Linux product that does the same thing. So it's a big vulnerability. People need to know about it. And if you report SQL injection to companies, many of them will actually fix that these days. They've actually understand, they're beginning to have heard of it somewhere, that that's actually a bad thing and they shouldn't have it. Although I got in trouble when I found a developer in Canada that had made 100,000 vulnerable sites. And I told him and some of his customers, and he freaked out and wrote articles about me in the press and said I had to be silenced, and contacted the college and demanded they fire me immediately for daring to accuse him of being insecure and stuff like that. But anyway, people are beginning to realize that it's a real thing. That is the fundamental problem with security. It's like you're learning witchcraft here, and people don't want to, if you talk to them, they assume you're evil if you know anything about this stuff, and you really should be hung and burned at the stake, and then we'll just pretend everything's fine and continue using our vulnerable servers. That was Microsoft's official position until about 15 years ago. They said, you know, all these people that find vulnerabilities should just shut up and everything will be fine. If we can find a way to just make them stop talking about it, everything will be fine. And they eventually decided that wasn't a practical plan and switched to the more modern plan where you admit your problems and patch them. But their original idea was that there are so few people that are smart enough to figure this out that if you don't tell anybody, nobody else will figure it out. There aren't any smart people in Russia or China or Pakistan or anything. None of those people really know how to hack. And they finally had to repent from that position. Yeah.
Why Oracle still offer the statements that your database is not hackable?
I don't know how, because I guess they think their customers are stupid enough to believe it. I mean, Oracle did have a long reputation of being secure, and so about 5 years ago at DEF CON, they brought a bunch of Oracle attacks. Oracle has injection attacks too, and the Department of Homeland Security came in and thought about silencing all those talks because they thought it was a threat to national security to expose that Oracle had injections, but they didn't stop them. And so, but I find the same thing. When I reported vulnerabilities to banks about 2 years ago, not one of them would even talk to me. There is no, if you find, go look at your bank's website and try to report a security vulnerability. There is no way to do it at all. They do not even have any process whatever to report security vulnerability. There is no one to talk to. There is no email address. They don't want to hear it. Their head is in the sand and they want to pretend there is no problem and they don't want to hear there's a problem. And they're still that way. And I think it's because the old corporate legal structure, see, there's a similar issue. I used to do litigation or product failures of fraud. As part of the Federal Trade Commission and related cases, I was an escrow agency. And at one time there was a Japanese computer manufacturer, Fujitsu, that was accused of doing something wrong. And when they came to America and they got sued, they said, okay, here's how it works. You have to go to court and deny that you did it. Then the other side has to bring up evidence. Then at a certain point you settle and make a fund and pay people, but you never admit that you did it. That's how it has to work in America. And they said, no, I want to admit that I did it, and then I will resign in disgrace. That is how we handle things in Japan. And they said, that might work in Japan, but you can never do that in America. If you admit you did the bad thing, then people can come back and demand more money forever, and it will never end. You have to deny that you did the bad thing, even when it's obvious that you did. That is the only position that will ever make it end. And the lawyer had great difficulty convincing the Japanese company to do it this way, but that's how it has to be done here. And so some of that continues, and so I think the problem is a bank can't admit they had a vulnerability, or they have to deny it and pretend it's not true even when it is true. I don't fully understand it, but I know in practice it's true. The security officers snuck up to me anonymously, quietly at a convention to talk to me and tell me that they can't officially say anything to me about this, but they actually noticed the vulnerability and they've decided whether they're going to do anything or not, but they can't talk about a vulnerability openly. Because I think if they did, it would have huge consequences for regulation and stock price and other things. It's not, the problem, the truth is a minor consideration in these big heavyweight politics issues. Anyway, so punctuation marks will often trigger SQL injection errors that tell you got these vulnerabilities, and there's a lot of scanners that will scan for them. At least as of about 5 years ago when I saw the last serious test, a thing to be aware of vulnerability scanners of all types is that they only find about half of the vulnerabilities they are designed to find. The most effective way to do it is human testing manually. The vuln scanners are useful as a supplement to human testing, but you must always test it yourself to be sure the vulnerabilities are there and to find them. So user authentication is a huge issue. There's another server somewhere with something like a database which determines whether people have come in with appropriate credentials, and you can watch to see whether they actually encrypted the data there. This is one of the blessings of Edward Snowden. For something like 10 years, the best practice from all the security experts we've been telling all the companies, you should be encrypting your local network traffic. Your website on campus should be HTTPS. Your connection for file shares should be encrypted, but nobody bothered. Not even Google, not even Yahoo, nobody did. On campus, they trust everything, use insecure protocols. They just encrypt it when it's going off campus. And when Snowden came out with his slides showing that the NSA figured this out and snuck listening points inside the corporation to sniff all that unencrypted traffic, they were humiliated enough that now people are starting to encrypt LAN traffic, which is a wise move. Because in the modern workplace with portable cell phones and iPads and everything, it is so easy to get a malicious device in your company that you're fooling yourself if you think it's okay to have unencrypted data inside your company. Anyway, that's a game here. Another thing to think about. And like I say, the platforms are typically Microsoft everything or LAMP, open source everything. Those are the most common arrangements. And of course, Oracle is there for the really big companies that can spend a lot of money on a database. And if you want, want a good job, you can go over to the CS department and get certified to run Oracle. That stuff is hard to run, and they pay big bucks for people to run it. It's complicated. Anyway, SQL injections are very common. A lot of attackers out there run scripts to find them. They dump them on Pastebin. You can find a dump of 10,000 SQL injection pages every couple of weeks there. They're usually small businesses that aren't really worth much, often in foreign countries, and people find the vulnerability and nobody even bothers to hack them for a long time because there's really not much there to steal, but they're vulnerable. And I used to go there and check these guys out and sometimes try to inform them before I discovered that that's all illegal. I think if you go there and report to them that they're on the list and do not verify it, that's legal, but I'm not willing to do that because 90% of them are not really vulnerable. Anyway, I actually had students doing that for homework years ago before I found out it's technically illegal. Now I steer clear of it. In general, this is what I was told by the old hands at security. They say, informing people that they have security problems is for chumps. You're just a fool. You only bother telling people that pay you to tell them. And it's not just that you're greedy, it's just the fact of life. I know you find this in I Ching and Writings of Confucius. They say, if a student doesn't come to you and say, I wish to learn from you, don't bother trying to teach them anything. They're not receptive yet. They still think they know everything. You have to wait for them to get humiliated enough to say, wait, I need to learn something before you can teach them. And so these people, just the fact that somebody found the vuln is no evidence at all that they're actually receptive to information about it. Anyway, so here's an error that comes up. By the way, if you go to this page, which I went to years ago, and put an apostrophe, you get this thing saying supplied argument is not a MySQL valid resource. This is not a SQL injection vulnerability. because it's not a syntax error. This is a normal application crash, where the fact it took this 55, we expected it to be a number, when you put an apostrophe in it, it's not a number anymore. That causes an error message, but it's not a vulnerability. This is a vulnerability. Let's see, I thought this one, oh, no, this one, the other one, fun to see. This is a welding supply site, and there were 110 of these a few years ago when I saw it on Twitter and checked it. This is their website, the way they intended to work. CGI bin, as2.pl, a Perl script, query equals select star for products. They just put the select query right there in the URL. So you can just type SQL here and run it. This is like having a command prompt with just a DOS prompt. This is not even SQL injection. They put the SQL right there where you can see it and change it. It's just incredible anybody to have a website like this. It's madness, and there are hundreds of them out there. And I highly recommend not trying to inform a company like this about security. They are far too stupid to talk to you about security issues. Anybody that would do this is so far gone, there's no saving them. You just have to let them sink. Yeah, that's true. They probably think this makes them secure. That's right. I mean, this just shows a deep, deep failure to comprehend anything that you bother to put on this security and you don't even see what's wrong with this. This is, like I say, this is why you need cryptographic experts, because if you look at what most people do for cryptography, it is this stupid. They don't even understand what they're doing at all. They just turn it on and they tell their boss, okay, it's safe now. I turned on that security thing. And they don't even know what they're doing. Here's local file inclusion, another common one. These are websites that have these vulnerabilities, so they have a PHP page that fetches a page from elsewhere, and you can fetch the page from some part of the server that's not supposed to be public, like ets password. That's also quite common. So here's an example of it. This is some game called Death Star, and if you just put page equal ets password, here's the password file printed out. Now the password file hasn't contained passwords since the 70s. It contains user account names though, and passwords are stored in a shadow file. But anyway, it shows that you have directory traversal, you can fetch files that you should not be able to see. And often you can fetch files from remote servers. So that's an issue. Anyway, so there's a OWASP testing guide for websites that has a whole lot of steps where you check for various things on the server, fingerprint the type of service, map the execution paths, and so on. OWASP has made a lot of recommendations how to really go through and secure your website. You have configuration and deployment testing to test their methods, whether they're using strict transport security, which is a very good idea. You can put a header on the website that tells the browser, don't load this page over HTTP. Get lost, go load it over HTTPS only. That is a very good idea. Then people cannot be downgraded with attacks like the SSL strip attack, not easily. And there's other tests here to test your identity management to see if, in fact, the user accounts are reasonably secure. You can check to see if the credentials are actually passed up in a good way and authentication is good. And if authentication is good, you can test to see if authorization is actually appropriate so that it limits what people are allowed to do based on their role, and that the sessions are managed correctly so it keeps track of who people are and doesn't let someone else steal the token and imitate you. And all the input validation where people are putting in data is checked to make sure that it doesn't allow dangerous input to be stored and used on the server. And the error handling doesn't leak things out. The cryptography isn't weak. The business logic doesn't do foolish things like let someone do something too many times a day. Like if someone lets you log in 100 times in 5 minutes, that's just stupid. They're obviously a criminal. You should block them if they fail login like 5 times or something, and so on. There's lots of things. There's client-side testing. It's quite a job. You can see why a lot of companies just throw up their hands and say, oh, turn on HTTPS and then tell our customers everything's secure. That's a whole lot more practical than really hiring someone that knows all this to actually go through our stuff.
Well, that's what the government's doing.
Well, that's what everyone's doing largely. That's why, security problems persist, because it's actually a lot of work to defend. I mean, that's why I always arrange the curriculum this way. First, you learn to attack. It's like several courses down the road that you begin to learn to defend, because defense is really hard. And it's a whole lot less exciting, too. Defense is kind of like doing your taxes. Here are the 100 things you need to do. Go make sure you did all of these 100 things. Go make sure that you can prove that you did those 100 things. That's the CISA class next semester. They'll pay you money for that. Security auditing. It's a big deal. It's somebody has to be able to prove to the regulatory agency that you really did all those things. And that's quite a job of management. Anyway, so my thing is acting strange here. Let me shrink it down so it stops messing with me. All right. So attackers use a lot of different tools. You can use the developer tools feature of your browser to see the requests and the responses in raw form. You can use Wireshark, but it won't do you much good if it's encrypted. Burp is better. You use it in this class for a few of the projects. Burp Suite Proxy sits in the middle, and then you can view requests and responses and alter them. Z-Attack Proxy is another similar product from OWASP, and it can even do some vulnerability scanning. There's a CGI scan product that's pretty old, but it looks for common misconfigured files on the server, and it certainly found a lot of bad things when I ran it against the WebGoat application from OWASP. The WAPD is something that lets you check to see how authentication methods are. It does a certain amount of vulnerability scanning on websites. And WFetch is the tool from Microsoft that checks how you're authenticating to the website. And in the world of Microsoft, you can use a lot of integrated authentication that takes your domain credentials and authenticates to the website, and the Microsoft tester will check those things. And that's WFetch, has a GUI here that just lets you see if you need to log in. There's also vulnerability scanners, which I've had very bad luck with. W3AF is a free one in Backtrack, and it's also in Corley. And when I run it, more than half the time it just crashes. And when I complain about it, the developers act surprised and say, "What are you doing?" But I haven't gotten into big discussions with them. The real vuln scanners seem to cost an awful lot of money, the professional ones. Skipfish is one Google had for a while. I don't think they're maintaining it anymore, but it's very effective at finding all the pages on a site, which is, of course, the main thing Google does. They're not that interested in vulnerabilities, although this attempts to be a vuln scanner, but they are very interested in finding all the pages so they can index them, and this one will really do that. And when I ran it against WebGoat, it did find like 49 SQL injections, so it's pretty effective. But I don't think it's being maintained. Most companies really pay the money for expensive vulnerability scannings like Accunetrics Hailstorm. Nessus now is a professional one that has a free version for student use. So that's one you could play with. These things typically run for 12 or 24 hours, create a ton of traffic, and give you a very long report, most of which is false. Most commonly, they will complain about problems and call them red letter vulnerabilities when in fact there's no real risk there. So you must have a human investigate afterwards and decide how much it really matters. If you just take the output of a vuln scanner and give it to a client, you're delivering miserable service and they will not hire you again, because you need a security expert to evaluate how much it means. And usually the vuln scanners are all set so they complain about every little thing and exaggerate its importance. And your client is paying you money to find out what really matters, not waste my time on stupid things that don't matter just because the scanner freaked out. Anyway, so what is this person trying to do? All right, looks like I can quit at 25. All right, that's SQL injection. Those attacks with the apostrophe, and that to make some kind of logical statement that will always be true, followed by a comment. That's one common form of SQL injection. All right. What's going on here? I'll quit at 25. All right, that is cross-site scripting. We're adding scripting tags where they don't really belong. All right. So what language is that? Quit at 25. All right, that is SQL, Structured Query Language. For the last few years, people tried NoSQL databases like Cassandra and stuff. They became very fashionable and Mongo and stuff, and then they kind of faded again. Most people found out it wasn't really worth the bother. But the thing about them is they didn't really synchronize 100%. So you put data in here, and it wasn't 100% identical across all the systems. Like a Facebook post might gradually move around the world instead of going all at once. And that turned out, they thought they would save a lot of resources for a lot of data that way, and as far as I know, most people sort of, the charm has gone off it, and they're finding out NoSQL is not that great. But you can do NoSQL injection and exploit them too, like Mongo and stuff. They still have formatted data, and it has delimiters, and if you sneak in unexpected delimiters, you can pump the data out of them too. So in addition to, I think, not saving as many server resources as people thought, they don't make you immune to this problem any more than Oracle does. Every database management system has some kind of injection weakness. All right. Because there was some way to send a valid request to dump out the data from the server. And so if I'm logging in, I'm sending a valid request, and it is possible to confuse it to think I'm sending the other valid request. You can't just say there should be no way to dump the data out of the server. There's got to be a way. And one thing that would seem kind of logical would be to have some totally different channel, like a different port with a different authentication for all the dangerous stuff, and have the login come in a separate channel, but that's not how it works in any of the server software that I'm aware of. Anyway, all right, what's going on here? This is a real attack against 2600, although it's been simplified a little. 2600 magazine had one of these. The only difference is they have like 100 of these slash marks was required. All right, I'll quit at 30. I think probably the most perfect description of this is local file inclusion, but directory traversal is the best of the answers on that list. You have somehow managed to take the web page, which should be showing only things intended to be shown to web servers, and you tricked it into handing out the /password file. So you tricked the web server into serving up a page that shouldn't have been public by traversing from the web directory up and over to some other directory. But it's not simple directory traversal because it wouldn't take so many slashes, and it would need dots in between. So it's something a little more complicated going on there.
What's the difference? If there's dots or no dots between those slashes?
What's that?
What's the difference if there's dots or no dots in between the slashes?
Oh, if you have a slash, that has no effect. It just stays in the current directory. A dot is the current directory, and dot is the directory above. So the only combination that actually does anything is // That moves up one directory. And so I typically see 3 or 4 slashes, and then /password. This is a little bit strange. All right, how about this one? Guess I'll quit at 60. All right, that's classic local file inclusion, where you have a PHP page that has a file name parameter, and you can just change that to point to some other file, and it'll review it. There's also remote file inclusion, where you could put HTTP in some other server and include data from some other server on the page. And those things are very common with PHP pages. All right, let me stop the recording and see who won the iClickers. This is 123, chapter 10B.